Hello, everyone. I forgot to prepare for the stream. So today we will continue working on the debug protocol because it's the most obvious task we have, or rather I have to work on. But first, let's of course start our motor, make sure it works, because I think it's currently... Oh, it will not work. Okay. Actually, let's start by unplugging the motor we used yesterday to test gravity compensation, and let's plug our demonstration motor. Okay, sorry for the late start. I'm kinda busy with moving out to Germany very soon. Okay, so where is my screwdriver? I see. I'm unprepared as always. How is everyone doing? Talk to me. So let's unscrew this. And that. And this. Very nice. And encoder, of course. And now we need to connect the longer encoder. Oh, that's a pain. Okay. A bit of fiddling, but I got it. Very nice. And also phases, of course. Here, and here. Very nice. This is stable. This is stable. And this is stable as well. Okay, so now we're talking. Let's turn on the power, and it still runs incorrect firmware. So let's flash it with a correct firmware, and what the correct firmware will be? It will be position controller. So let's flash it. Okay, of course we need to connect our debugger, little bugger, and do this. A moment, we are almost there. And run. Let's see, so it's calibrate itself. Let's see if we broke anything yesterday, because yesterday I was removing our gravity compensation code into a separate example, so I'm not sure if I cleaned everything up correctly. So let's see, and now I should start spinning, hopefully, and start, and hopefully it will go again, but to the opposite direction. Nice. So now that we have attention grabber active, we can go and start working on our debug protocol. And the debug protocol will continue changing. I actually re-implementing probably 95% of it, but it will worth it in the end. So the last thing we were doing on the debug protocol, and I was doing it on stream mostly, I just updated it off stream after this, is re-implementing buffers, and we added a description string. And now the main idea for the protocol I would like to be able to implement, which I know how to, it's just a matter of time, is that I would like for the system to be self-descriptive. What it means is that when the master connects, master should be able to read the structure of everything the system can provide from the system itself. So the system has to self-describe itself, and when it does, master can decide what it wants to tackle. And the way to achieve it, the way to implement it, is by having descriptions for everything we register and to be able to register everything. And this is currently only supported for our buffers. And error log doesn't need any explanation because it stores errors, and it needs only a version, and version is sent. So from the version we already know how it works. So now we need to change everything else, basically, and everything else is our write commands, general commands, and also our streams. So we will need to work on all of it. But first, before we start tackling this, I also want to clean up an SVM implementation from yesterday, because it is a bit of a mess and I don't like it much. And it is a bit of a mess because the flag that is needed for me to switch to SVM has to be in a wrong location. Like, I would like it to be in this file, but currently, with current implementation, I have to have it here. Like, I have to have this flag here, which is this one. And I would like to move it to the main because it doesn't supposed to be a device flag. It's supposed to be a testing flag that should go away with time when we are confident in our SVM implementation. And why do we have to have it here? Because I'm a dumbass. As some of you may already know who were watching streams before. So let's fix it. So the issue comes from the implementation itself, which is here, and from these flags. And I don't want those here because those are annoying. What I want here instead are two different defines, because who knows, maybe in some situations we would like a sinusoidal modulation. For example, if we work with, I don't know, BLDC motors, or maybe for BLDC motors, when we will implement separate BLDC controls that will not be an FOC, we will have a separate factor as well. So who knows? And because of this, I just want to use FOC, sinusoidal modulation factor. And this will be 0.5, of course, because when we control with pure sines, we have half of our bus voltage available for our phases. And what FOC provides, so let's define FOC SVM modulation factor. Actually, no, this is correct. This is actually correct. Actually, this is correct. We also need to do 3-phase because it's important. And this is a very conceptual moment, because if you have FOC for more than 3 phases, because it's possible, you can easily make motors that are like any arbitrary number of phases. You better do it an odd number, not like 4 phases, but rather 5 phases, but you can do it. You can have an electric motor with 5 phases if you want to, and maybe there are technical reasons to do so. And if this is the case, this factor changes actually. So this factor will be different. So 3 phases here is important. So it will be FOC, 3-phase sinusoidal modulation factor. So this is now correct value, because who knows, maybe in the future, just for fun, I would like to like design or try to control a motor that is like not 3 phases, just for the learning opportunity. Because to know 3 phases, you might as well, you cannot claim that you understand how 3-phase motors work unless you can make one, and maybe you can make a motor of like different combination of phases so that you can actually prove that you understand stuff. And I cannot say that I understand 3-phase motors. Even though I implemented FOC from scratch, I still don't think I understand it normally. I still have quite a long way to go to claim this. So FOC 3-phase SVM modulation factor will be, of course, 1 divided by square root of 3. So 5577 35027F. Very nice. And the comments above are correct. So let's do this. Very good. Do we have to have anything else in this file particularly? Do we need to have anything? So define the enable space examination. No, this must not be here, and I don't think it's even used in this file. So yes, this has to go. Raises the linear output range from Okay, this is not important. So all of it goes away. Needed for our mass to work. Why though? Can't I just include CMAS directly? Arm mass rather? Arm mass that each. And without this, will it work? Let's see if we have any problems. We do. But these problems are not in this file. So this file works now. And are any of those used? I don't think they are used as well. So let's see. Oh no, they are used. Inverter 3 phases, and we use this, and this is stored where? In Hopel utils, sure. And where are they? Where are they? Like actually, where are they? Actually, hello? Was? External, oh my god, it's also a file in here. Oh my god, I actually need to move all of this, and I completely forgot about the existence of these things. And what is this? Average angle reserve flow, those are not needed at all because we already implemented this again. So we have this, and this is kind of important, but it has to go. It has to go somewhere. To do move to dependencies, because this is a very generic file that has to go to dependencies. Move to dependencies and improve. And I also need to remind myself in main because I completely forgot that this file even exists, which is unfortunate. Move Hopel constant vectors .h to dependencies and improve the file. Okay, so we move it to 2 locations. Now we know that it's a work we have to do, and we have a few things broken. We will break every include, but I don't think many places use it. Or do they? Oh. Hold on a second. Device, let's see. Oh no. Hold on a second. Have I broken something? Do I actually need this file? Hold on a second. Do I actually need it? I thought I moved this out, but I didn't. So actually, then I also need to move this. The more you know, the more you know. Rename the file and or move the function to a different location that is more suitable for it. So this is also work to do. But yes, currently it is used. Okay, I pulled the trigger too fast. I'm sorry. I'm terribly sorry. Okay, so this builds now. But here, so this will break. And here, what we will do is we will say define define what? Define. Oh, it's not here, it's in here. This one. Let's move it away from there to our main file. And let's remove it. And let's also actually, okay. If def FOC use SVM else and if. Okay, so what we will have here is rather simple. And hold on a second, what happened? Okay, so we will define this one. So define this one as the things we defined in our FOC file. So, and our FOC file is actually, I need to make my screen bigger. I forgot, I'm terribly sorry. These are these factors. So if we use our SVM, we need to define it like this. And if we don't, we need to define it like that. That should fix all our issues and should make code more scalable, easier to move around. Actually, it's too big. Hello. Okay. Like that. So we don't have any errors any longer, which means that we successfully improved things, but we would like to use FOC or rather SVM, of course, because SVM gives us free voltage for nothing. Also, I'm quite curious to see the performance of the function with SVM. So let's actually measure the performance because I'm rather curious. So let's copy this section to our SVM calculation function, wherever it is. It is here. And also let's move this function. Let's comment this out and move this one to the same location. To almost the same location. Any moment. Here. So now we will profile this function, and I'm very curious how much time. Actually, let's profile both of them. So let's actually do it like this, and we will use FOC and not FOC because I'm very curious about the performance. Actually, SVM should probably increase the performance because it doesn't require us to calculate too many sine functions, too many trigonometry. But who knows? So let's do it. Let's flash it. Currently, we flash it with SVM enabled. As you do. So now let's run it. It will calibrate itself, of course, and we will, in the meantime, go to our lot of expressions to see our estimations of our performance. Okay, very nice. So the performance of our SVM is 174 cycles. Kinda a bit too much. I actually expected it to be lower. Let me see if I measured it correctly. So we measure 3 to 4 and store it into 2. Correct. And the function should be relatively simple. Or is it? It's like 6, 9, 12 operations, 13, 14, and okay. 174 makes sense. Okay, it's quite a lot of operations. But now let's go and disable SVM, and let's measure the performance of the function that uses sinusoidal modulation. So let's see how it compares. Let's see. Okay, let's run. Let's wait for us to calibrate and open our estimations, of course. And let's see. With sinusoidal, we have, we have almost 600 on average. Ooh, so SVM does improve our performance quite a bit. And it's also improved our voltage quite a bit. Okay, this is very interesting to know that SVM is much better than sinusoidal modulation. So now let's go back to SVM implementation and let's unguard the function and let's measure the performance of the whole FOC cycle. So let's move this back. Let's move this out and this out and this out and go to our beginning, to the beginning of our FOC interrupt, just here. So let's measure this and let's see how our overall performance of our FOC currently looks like. How many cycles do we use? And therefore, how many cycles do we have spare? And run. So wait for the calibration, of course, and let's see. The number should be here, and here we will see a delay between our encoder measurement and our FOC cycle. Oh, so it's 1300, and we have it on 1600. So, holy cow! I never thought that I will be like making the FOC loop more and more complicated and developed, and that the performance will actually improve. Okay. So effectively, currently for FOC, we only use this number and this number together, -4, which is roughly, so sometimes it jumps to 1600 because sometimes it jumps to position controller. So let's see. When it is at position controller, it takes 1600. So let's see. Let's assume it's 1620 plus 107 -4. It will be 107.23. And this is roughly, and we have available 7500 at 20 kilohertz FOC frequency. So we are taking roughly 21.5% roughly. Let me check my math with the calculator of the performance with RFOC, and this actually looks very nice. If I would manage to finish the whole implementation with this, I actually believe that I can easily design a controller that will control 2 motors at the same time, because the performance will allow us to do this, and this will be completely independent for both. Especially, oh my god! Actually, let's think about it. Where is my calculator? Again, oh, it's actually such an interesting idea. Hello. So let's divide our 1073 by 7500, and this is 20. Okay, my math was off. Why was it off? Because I am, why? 1 second, am I stupid? Why is it 22%? What? Oh, I know why. Okay. Don't do mental math. Okay. Because it's 75 per 1. Okay. So use 23% roughly. But it's still very good. So now thinking about it now. What we see here. Oh, but this is active performance. But actual time that happens from the beginning to the end of this is actually this number plus the number we wait for encoder data, which is this number. So technically we are at around 307 roughly, also -2, so it will be -2. And I do -2 and -4 because the functions to profile code take 2 cycles to finalize themselves. So, and this is roughly 40%. Don't quote me on that, of course. And what my thought is that this value is constant. So this value is constant and parallel no matter how many encoders we use. And also one more thing. This value can also be improved after we fix the encoder noise when we use 10 megahertz instead of 5. So we can actually just slash this number in half and it will be like 700 for communication delay. And the point is that we will assume that for every motor we will add in parallel to our control loop, we will add this number. So this number will be added roughly for every motor we have. And it's also will be like 80%. So for every motor, we would try to add onto our PCB to control from the single microcontroller. We will need to add roughly this 90% of this. And why 90%? Because interrupts will be the same, so we will not have any overhead for interrupt calls. We will also not have any separate checks for position controller and current controller and stuff like this, because all these if-elses will be synchronized, so we will use same. So we will actually has smaller overhead. And this means that even with two motors attached to a single microcontroller, we will be able to still have half of our performance, half of our processing time available for something else, which is very nice. But the actual issue becomes the availability of hardware, because currently my controller, if I believe, uses at least three SPI. So we use one SPI to communicate with our, let me think. Let the man talk to himself, right? So I have one SPI going here. We also have one SPI for each encoder. And I believe that we have more. Actually, let's open. I think I just have a file that stores my connection scheme. So let's just open it. One moment. We're getting there. Electronics here, pinout, this and that. So let's open. Because controlling two PMSM motors at the same time is allowing us in a synchronous way to do a lot of fun stuff without a need to synchronize anything and to bother with communication protocols and stuff with anything. So this is our connection scheme as STM32 cube MX file. It's very useful to use when you work in a team to move from PCB designer to software developer, firmware developer. So let's see, connectivity. Okay, so I use three SPIs and those are only SPIs that are available at this device. And let's actually see. Let me open another microcontroller. How many SPIs does it have? Because for every motor, I will need two SPIs each. So let me open Cube, STM32, Cube MX. Nice. And let's see how many motors can we push on our single microcontroller, peripheral wise. So let's take the beefiest STM32G4 we can find. And also I know. We are limited not by the SPI peripherals, we are limited by the timers peripherals. And the good thing is that I don't use high resolution timer, I use just precision timer, which is timer 1. And I then will be able to use timer 4, not 4 but 8 for a second motor. And that's all. I will not have any other timers that will be in a similar fashion available to control more motors. So I think 2 motors is an effective limit on how many motors you can put on a single microcontroller. But let's see if we have more SPIs available anyways. After we started this after all anyways, right? So let's finish it. G474 is the beefiest one, and what will be the big body? What will be the big body? So something like C is 64 or 48 even, okay. And where are R64. So it's R. R doesn't look nice. So let's use M, which is 80 pin body. MBT6, whatever. So let's see. It should be an 80 pin microcontroller, if I remember correctly. And if I'm not, that's my bad. It is. It is an 80 pin. And let's see connectivity. We have 4 SPIs. So 4 SPIs is exactly 2 motors in our situation. So let's see if we can full duplex, full duplex, full duplex. Just roughly sketch it. Sketch if we can do it full duplex as well. It's all over the place. I actually hate this. Can we move it here? SPI clock, please. Oh, was you. Nice. Okay. And also, let's see if we have 3 separate. Oh, no. No. Oh, actually, another limiting factor for us using 2 microcontrollers on a single, 2 drivers on a single microcontroller is an ADC availability. So we will need 4 separate ADCs, actually 5 of them. Holy cow. So let's see. We need to find a single pin on every single ADC available. So this will be ADC 1, let's say. This will be ADC 2, let's say. This will be ADC. It's still 1. It's still 2. Still 2. What are the pins available? Hello? ADC 3. Okay. 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 ADC 3, another pin, let's say. Okay, so this is quite a nice pin. It's available on all higher end ADCs. So let's say ADC 4, ADC 3. Actually, how many pins do we have here at all? Quite a few. Oh, quite a few actually. And here as well. Hello. And what will be this? Oh, but I don't need differential, I need single end. Okay, but this is quite far. I would like my whole analog stuff be here, if possible. So, oh, so this is ADC 5 then. Okay, this is much easier than expected. And this can be, oh, okay, so this is not a problem as well. So we can do this. And we can have our 4 SPIs. And can we also have our timers at the same time? Because this will just generally solve all the issues. So slave mode, no, just enable the PWM generation on channel 1, PWM generation channels 2, and PWM generation channels 3. Okay, so they are moved actually, because I think they have pins on this side. Very interesting. And we also have to do this for timer 8 as well. So we will use PWM on channel 1, PWM on channel 3, 2 and 3. Okay, this looks incredibly easy to do then. Holy cow. Actually, do we have quad SPI available? Because thinking about it now, like if I think about this as my next project to implement on stream, I would like to make it fancy, right? And how do we make it fancy? We don't. And why do we not have it available? I'm rather curious. Let's reset a few pins here. Because if I were to make this project and to make it fancy, I would love to use Ethercat as our communication protocol. Oh, and now it's available. Let's see. A bank 1 with single dual lines with wide SPN lines. I'm not sure the difference, but I'm sure that I need... Oh my god, what the hell is this? This looks awful. What? Oh no, it doesn't actually. It doesn't look that awful. So quad SPI, this quad SPI clock. Okay. This looks promising. Quad SPI PK1IO3. Can I move it here? Oh, I can. Oh no, it's plus. What is that? Are those different? Oh, they are different. Holy cow. Oh my god, I can do like 8 pins for quad SPI. Hello? Can I move a pin here? Because this pin looks completely out of place. Completely out of place. And this pin as well. And this pin actually. Like, who does this? Oh, because SPI1 is in a way. Let's move SPI1 out of the way actually. Let's see if it looks fancy enough. Let's see if it looks fancy enough. Remove this. Go back to our quad SPI. Disable, enable this. Was. It still had to use. At least we don't have a pin here. We have IO3, IO2, IO1, IO0. That looks nicer, but not very nice actually. And if I enable it here, oh, okay. And I need to move CLK for SPI1. Okay, this is very nice actually. It is even nicer. This is so much nicer. But I had to move timer 1 channel here. Oh, this is unfortunate as hell. Because I have to use this pin. Do we have another way to put this pin, like somewhere? Anywhere? Can I swap them? No, that switches out our quad SPI. And I cannot do this because if I do this, I will... Do I have another place where I can put timer 1? Oh, I can move it here. As it's supposed to be actually. Oh, but this is timer 2. What I've done? Actually, what I've done. Hold on a second. What am I doing? No, but it's correct. I just dumbass. Actually, it is correct. So this and this and this. Oh, now it's look much better. And we still have access to multi-ADCP lines here. We have our quad SPI and we actually can move our ADCs from here to not intercept with quad SPI at all. And we have our 4 SPIs available. And we have our 2 timers. So this is actually possible. We can do a very nice, very well thought through motor driver for 2 BLDC motors at the same time, which will be fully synchronized. So for example, projects like, I don't know, balancing robots or SCADA robots can be done this way on a single PCB on a single motor driver. And this looks hella impressive, hella interesting, hella nice. I like it. So I actually like that I've done it because I know that it's a complete and even easy possibility to just do it if I want to do it. Now, that was quite a way to distract myself. Let's get back to our actual work for the day, shall we? Okay. So cleanup SVM implementation done. What comes next? Next, we go to our debug protocol and we start grinding it. So let's switch the mode. We don't need this any longer, at least for now. And let's go and start developing debug further, or rather redeveloping it from scratch. Where is it? Where is it? It shall be in here, first part. And the first part is our... What? Isn't here? Oh, hold on a second, because debug is not related to microcontrollers. Of course. So it's here. My bad. and we are in this file, and we will start blasting very soon. We also need a C version of this file, of course, to start blasting as well. And let's actually split the screen after all. And we will move all our, let's see, let's close everything we don't need. Okay, this, and this, and that, and this, and probably one of those, and this. Oh my god, how many files do I have open? Hello? Oh my god. And this, like that. And now let's also open our UART protocol. And where is it? So it will be H file and it will be a C file. And let's clean this up before we start blasting. And here it is. It's kind of a lot of files, but only one C and one H. So C will go here. And H will go here. So the first thing we need to implement now is the support for registration for write and read events. Currently, how it's done. In current implementation of the debug protocol, our read and write events expect they expect to know, like master expects it to know what slave can do. So slave should implement something and master is supposed to know what slave implemented, and this is the way they communicate. And what I want to do is for slave to be independent of the master so that we don't need to develop a new master every time we change the configuration of this on the slave. So every time we change what parameters we can write or what we can read or what we can call, what functions can we call. So I don't want it to be the case. And how do we do it? We do it in the same way that we designed for our debug buffers and for our streams. So we will introduce a queue, a registration queue for both write events and read events, or rather call events, because we actually don't read anything using our call events. And how will we do this? We need first of all to provide definitions for size, because we don't want to store full RAM of our debug protocol definitions. Because debug protocol, debug interface actually consumes quite a lot of RAM on our microcontroller, which we don't want to share easily. So let's actually make sure that this is controllable by the device itself. And how will we do this? So even def debug max what? Let's think. I actually think I come up with a better name this time. And it's request so count. So this will be the name for it, and if. And also, none of this and ifs is in my style, and I need to fix it now. So let's quickly fix it, because otherwise it hurts my feelings to see the situation. One moment, I need to close a gap in my mental model. Okay. Close this. Oh my god, what is that? I copied a bit too much. And let's do this, but with this. So now it is actually nice. Actually, now it actually looks worse than it looked before. Hello? It's actually look worse. You know what? Actually, I decided just now that I will change my style. That for one-liners, I will not provide this at all. I think this is much easier, much cleaner to read. So if we have a one-liner, we will not provide a comment explaining what it closes out. This is not a one-liner, this is an else statement, then. And then this also the case here. Because this is just too much text that doesn't produce any value, only introduces noise on the screen. And looking at this, I like it much more because it's easily understandable as is. So let's define it as, let's say 32 is normal enough, I'd say, as a default. And we will also have a similar value for our write parameters. So if in def debug max parameters max count. So define this value and if, and also if no def. And this default will also be 32, and we also need to make sure that it is unsigned like that. Here, if I'm honest, I think this should also be a variable number, because if it isn't a variable number and every single parameter will expect to have it, we will quite literally have a RAM full of just parameter descriptions that are empty, because 32 characters is quite a lot. So actually, let's change default to 16, because I would imagine it'd still be big enough. And let's also make it changeable by the user, by the firmware developer. So if in def this value, we end if and define it as 16. So we will use 16 bytes, 16 characters by default. And I don't think anything breaks, because I think that all our examples that are currently implemented, which are those, still fit 16 characters. So how many is this? It's 14. So it actually fits very nicely, even like quite expressive text. And when we will do parameters, we will use for something like speed, RPM, or like torque, or like KI, like something like this. So we don't need to have 32, and we, by slashing it from 32 to 16, we could like simply slashed our RAM footprint by half. And if particular case, particular application needs more, we also added an ability to redefine this value without touching this particular file by itself. So this is nice and very useful. Now, this was the easy part. Now comes the hard part. And the hard part is to design a structure. Oh, it's another easy part, because it will be just type def struct, and it will be debug. Debug. Oh, actually, I thought before that. Oh, I remembered. I had an issue when we were working with debug buffers that we had to call a debug buffer. And now I know how to solve it, because debug buffer here buffers stream pool, and let's call it buffers pool as well, because this is literally a pool of registered buffers. So let's call it a pool, and then we will also call our requests a pool of requests, and like read request and write request as pools, because we have pools of registered values. So it makes so much sense now. Okay. Let's get back to implementing this. So what will it be? It will be debug. Request. It actually will be debug request first. We need to define the request itself. And the debug request will be described in a single way. It will actually have a single field, which is a description field. And we also need a pool of those. So let's define a pool. A type def struct debug requests. But let's think about it. This is awful. So the X request error log, those are independent, debug buffer and debug buffers. Let's quite literally call it a pool, because this actually makes sense. And debug streams pool will also... Actually, I need to check if the pool is spelled like this. Because if I use an incorrect word for the pool, it will be actually quite embarrassing. No, it is a correct word. Okay, it's correct spelling. I'm saved. I am saved. Now, so what do we do here? We change this and everything breaks. And because everything breaks, we will need to go and clean a lot of stuff. But it is a nice change. Oh my god, it broke so many things. Oh my god. Okay, that will take a moment of my time. Hold. Stand by. Stand by for the updates. Oh, and now in streams, we can actually also rename this as well. Because we used registered streams to separate streams from streams, but now that we have streams pool, we can remove this, and we also can do the same for buffers, I would imagine. Right? Buffers. I see. I messed up quite a few things, actually. Okay. Not a big deal at all. We will fix all of it. It's just a naming thing. So it will be just streams to make it shorter. And why do I even have it here, actually? Entry field types, no type. What is this? Oh, this is a register stream. Okay, this functionality is important and it's also tested. So here. Oh, and it also reads better. Oh my god, it's actually such a nice improvement. Streams, pulled, next, right index. It reads much better. It reads much better. So we also have quite a few mentions here. Not a big deal. Let's fix it. Not a big deal at all. And here, and here, and here. And also here. And here, and here, and this. And that. And this. Very nice, very nice. Oh, I missed one. My bad. So now it should be fixed, right? No. Now it should be fixed, right? Yes. Okay, so we fixed the naming, and naming now is much better, and also streams are consistent with buffers because they were not before, which is my fault, of course, and not a big deal because now we have a naming convention we can use. So with debug requests, there will be a pool, and the pool of debug requests will be the pool of pointers, of course, not pool of members. So it will be a debug request dot pass not debug request pointer, and how we called it to be just, it's actually say requests, and it will be, no, hold on a second, it should be an array. It should be an array of pointers, of course, and the length of the array will be a debug that we just introduced, requests Oh, actually, what we introduced, I don't remember already. Max request count, sure. Debug max request count. So we have an array of our requests we can design, we can add, and we also have a variable to store our next request. Do we need to add anything else to our requests? You know what? I actually don't think we need to add anything to the request, but now I'm thinking that I should probably make a separate field, separate define for the length of the request descriptions. Because I would imagine from all the primitives we have, which are buffers, streams, request, write request, not write request, requests and writes, parameter writes, requests will need the longest description because they need to meaningfully describe what they're doing. And from this standpoint, they may as well need more characters than everything else. So let me actually, shall I, from the same logic, then just enforce, not enforce, but create a define to make separate lengths for everything at this point, for every description, because why not? Because there is absolutely no reason, no design reason to have all descriptions of the same length. Because for optimization reason, we might as well then slash some of them up to the minimal we already have implemented. You know what? No one talks to me today in the chat, but I think this is a nice idea, so I will do this. And how will I do this? And this will be fields count and also max stream count, so they should be close. So it will be stream related, and we also will introduce if def. Is this correct? Actually, wait a second. Oh no, but if I do it like this. No. This is actually a problem now. Because our master expects to know the size of the description field. And us doing this will actually mess up with our master, because master reads a fixed number of values. It doesn't expect an null-terminated string. It expects a string of known size. So how can we solve it? We have a request to read buffer description, and we can send in this request length of the description field in buffers. And given that we will have the same for stream description, actually, you know what? We will do this. We will do this. And I will not hold back. Because this is not hard at all. And it can be very useful for optimization purposes. And if I don't do it now, I will never do it. So let's do it. Let's actually just do it. So I break my protocol again. We will have to rewrite stuff for debug buffers again, but not that much, but still. Let's do it. So debug max stream description len. And this will be, let's say, 16. By default, they will all be the same. So let's define it. Define. By default, they will all be 16. But a user will be able to manually change description on all of them, and we will implement functionalities that will allow our master to know how much to expect. This is actually kind of smart. I like this a lot. Max stream fields count, max stream counts, let's move it up. This will read better. And this is a correct. No, we don't have any actual limit for lang, any unreasonable limit. Oh, actually, no. To do add an error check on the protocol side to not be bigger than uint 16t, or else I will find you and I will kill you. Or else we will not be able to send the whole thing in a single DMA transfer. Nice. So I will do it a bit later. Let's see. Is this checked? I think this should also be checked. So to do at an error check. Actually, I think it should be checked. Is it checked? It is checked. So it has an error check already. So this to do is unnecessary. Here, max streams counts. Do we have an error check here? How is it defined? It also must not be bigger than this value, because we send the number of registered streams as a uint 8 value. So let's see if the error check for this exists. It doesn't exist. So let's add it. So let's copy this one. Yoink. Oops. This one. And let's add it here and here. Must be less or equals to 0.xff due to uint type used to index streams. Type used to what? To index stream fields. Okay, and let's actually just implement this check, because why not? And this check will be implemented on the protocol side, which is here, but in H file. So here, what we will do is we will do this error, but for streams. And how will we write it? This value, max stream description len. If this value is bigger than just this requirement is needed to ensure that the whole error log can be sent in UART in a single email request. Yes, this requirement is... I don't need this comment. I just need to write a proper explanation, because this comment just duplicates this, right? So let's rewrite it in a way so that we can remove this comment, because it is unnecessary. It's just in our way. It's too much noise. I woke up today and I decided that too many comments is too much noise. So let's remove what we can remove safely without losing any meaningful information. So error log must not take more than uint32 bytes. Yes. So that it can be... Can I use a multi-line? I cannot be sent in a single DMA transfer. Please use small value for this. Definition is unnecessary. And this command can go because we already explained it here. All right. Very nice. And we can remove this and also this. This should stay because it encapsulates all of those. Let's rewrite this as well. Like if we start it and if we still don't have anything more interesting to do, let's just keep cleaning. Let's keep cleaning up. This requirement is needed to ensure that the whole buffer can be sent using QR. Sure. Buffer size must not take more than these bytes. So actually, hold on a second. Does this make sense now? Because this variable is not used any longer. It is never used anymore because we changed how debug buffers work. Actually, search. This is a broken example that will not work. And this is a broken example that will not work. Sure, this will not work. Here is the definition. We have it here as was. Okay, this is here, but also what is that? No, what is this? Oh, okay, sure. Whatever. We have one here. Oh, it's open on the right side. I'm a dumbass. Hold on a second. Okay. And here it's in commented section. So sure, it's not important here. And here it is in a commented section as well. And other two places we have are here, which is an error check, and actually on the very same line. So this has to go. We don't have it anymore. And this has to go as well. Then, and also, this has to go then. This can stay, but I has to remember to update this template when I'm done updating the bug protocol. Boom. Boom, bam, bam. Okay. So everything else are examples that are broken anyways. So we are not bothered that much with them. Okay. Now, what were we working on actually? What is this issue? Let's run a build and let's see if it still persists. It does persist. So, and what it tells us. Useless storage class specifier in empty declaration. Was. I have no idea what it means. So let's keep it for now. Interesting. Oh, I know. I'm stupid. This is what you're trying to tell me, right? Yes. Oh my God. My bad. So now we have a pool for requests, and let's also for just for requests. For send request, and let's make a pool for parameters. So type def struct debug parameter, and debug parameter will have more fields. It will have description. Oh, I remember we were working on a different thing. I jumped from thing to thing. I'm so sorry. We were working here on this one, and we were planning to redesign the debug protocol first. Let's actually do this first. First things first, of course. Now we added. Did we add this error check actually? Oh my God, what I'm pressing. I actually don't think we added it, right? Did we? Did we add it? Oh, we did. Oh, but we forgot to change the description. Oh my God, I jumped from thing to thing. Holy cow, I'm so unorganized today. I'm terribly sorry for anyone who's watching. Okay, and it's also a wrong name. Okay, wrong description. So, debug stream description description must not take. Actually, you know what? We have to change. Actually, must not take more than 2. So that it can be sent in a single PMA transfer. So please use smaller value for this. Or rather, I can remove 4 if I structure my sentence like use smaller this value. And this is optimization of our reading capacity. So we removed a word, and I also not sure if this spelling is correct. So let me actually double check it in my secret location. So let's see if the spelling is correct. It seems like it is a not. Please use a smaller value. And also, I think I don't need this comma. Let me check this as well. To not spawn errors. Okay. A smaller value. Okay, spelling is checked. This works. Does it work correctly, right? It does. So a single value like this will be like 65 kilobytes. If anyone uses so much, they are terribly, like a terrible person. Actually, let's add another error check. Not error check, but rather a warning. And let's remove this. If this value is bigger than 174, and if warning, you are most likely use too much RAM for your stream descriptions, please reconsider your life choices. I think this will be a nice error to have. Not an error, but a warning. So it will be still allowed. But the person who will write this should be ashamed of themselves. Hold on a second. Reconsider. So I'm not forcing an architecture on a person, but I highly suggest to think about it. Highly suggest. Actually, I actually think that this value can be lower. You don't even supposed to have this. It's still too much, but at this point I'm like jumping a gun a bit. So let's keep it like this. Okay. So back to our struggles. This is not the correct file. This is the correct file. So these are all the definitions for, and now we implemented this, so we don't need to have any comment here. Or do we? Sorry. Do we have to have a comment here? I don't think so. I don't think so. So note, in theory, we don't need to limit number of fields. But to make things simpler to work with, we introduce the limit if you need. Okay. I think this node has to be moved up as a general node for this whole section, because the whole section exists just because we would like to be able to save RAM by just lowering the amount of stuff we add to the debug protocol, because the debug protocol is very RAM hungry and we can add like a million things into debug so that we can debug them at the same time. And this is very flexible on this side of things, but this node is needed, not here, just not here. So to do, move this node to the beginning of this defining a section, and area right is as applicable to the whole section. Nice. Now, this is actually not a part of this section, so it will be changed a bit, but it's not a big deal for now. This is all right, sure. This is all right as well. Number of messages. Yes, this should actually not be here, I think. This one doesn't. Actually, it kind of does, because the idea is the same. We want to lower the usage of RAM, but this... Actually, hold on a second. No, it does. Yes, it has the same idea that we would like to use smaller RAM for our protocol. But compared to all of them, these are compile time parameters that will known, like the breakage of these parameters will be known most often at compile time, or actually at runtime as well. But this can actually affect performance, because this is how many messages can be queued in our queue that goes to our UART or any other protocol. So this is actually performance critical parameter. And like before it was 6, and given the changes we introduced to protocol, we send more data in smaller packages. We need higher capacity so that we don't have an issue when we accidentally overwrite what we don't want to overwrite, or like just run out of our queue space to send all the data we want to send. So let's keep it like this. And let's continue working. We were planning to do what? To re-implement again our debug buffers. So max buffers count, sure. And also max description length. Actually, now that we have this, we have to go here. And where are our streams? Max streams count and the stream max stream field count, and description here has to be char, not char pointer, and this needs to be that stream description length. Very nice. Very nice. Actually, I am very hungry. I think I will do a 5-minute break and I will go and fetch myself a snack. If no one minds, I hope no one minds, and I will go breathe some air because my thinking today is kind of messed up. I'm terribly sorry. Okay, so let me do a short break. I'm back. For anyone wondering where I was. So now, I had a snack, actually 2 snacks. I drank some water and I got some fresh air. So my mind should be better. Now, where were we? We were designing the change to our debug buffers. So let's finish it. Now, max request count. It, not it. One moment. I bought a soda and it runs out of me. I'm terribly sorry. Now, this value must not be bigger than this. And we also need to add an error to this file actually. And this error already exists. Very nice. Hold on a second. Oh, so errors for both buffers and streams exist. Okay, sure. Nice. And here, if def debug, and what is the naming convention? It is max buffers buffer description length. So max buffer description one. Nice. If it is not defined, we need to define it. This is the way you make your file changeable from the outside if you want to give your user an ability to change this number later without changing the file itself. So let's use 16 here. Actually, should I use characters instead of length here? But description also already assumes that it uses characters, right? I think so. So we will need to do add error to the protocol side here. Why do we have 3 here? Because we have fields which we don't have in buffers, and we have max count, which shall be 16 by default, let's say. And this looks good to me. So now we need to use this in our buffer structure. And a buffer structure is... I need to add separators here. It's actually impossible to find what I want fast to do. Add separators for each type of objects of debug objects. Oh my god, I can't spell today. So, requests, error log, buffers. Debug max buffer description length. Should I use just buffer description length? Because max is too many letters and it's kind of... Okay, no, max is correct. Max is a limitation, like max is a valuable addition to this. But this has to be gone, and let's actually remove it right away so that we have many errors and we fix them right away. To not forget to do it later. So this is broken, of course, and this we will need to add 2 more fields like this, which is easy to do. So we will separate our requests and our parameters into separate definitions, and this will be debug max request description length, add it here, change the tabulation, and here it will be max parameter description length. Very nice. Change the tabulation, of course. So, and here we need to fix it. So it will be debug max request description So this is fixed. We don't supposed to have any errors unless we do, of course. And here, this is actually a part that we will need to handle right away, correct? Because we introduced this part. Actually, no, a few more things before we fix this one. A few more things. Let's add this here. Because all our pools currently will expect not 16, but rather a uint8 value, which is 256, or rather 255 fields maximum. So we cannot have more than 256 parameters. We cannot have more than 256 requests. And I would imagine that this is more than enough for most systems. And maybe in the future, if this will not be enough, actually, this is a long term to do. Very long term. Think about allowing structures as parameters, question mark. How will it work? It will actually go nicely around this limitation for very complex systems. Because maybe, actually, does it make sense? It may make sense because, for example, if we want to write parameters for PID controller, and let's say this PID controller has P, I, and D, we might as well want to use a struct of 3 variables that will be sent at the same time. And the PID controller also have a lower limit, like a low limit, a high limit. And for a control system, for a single motor, you have 3 controllers in the main loop, and then also a controller for brake resistor. And the controller, actually, you have 4 controllers in the main loop because we have 2 current controllers, because it has a separate flux controller and a separate current controller. So we have 5 controllers for a single motor. And if we calculate it like this, even if we assume that they also only have P and I, it's like 4 parameters per one. So just to describe one motor, we already has to use 16 parameters, which is quite a lot actually. And this is a single motor, and this doesn't assume that we limit the tasks in any way. On the other hand, do we have many more parameters we would like to set? Oh no, we also have output limits. But no, the output limits I just described. Actually, let's open up a controller. Let's see how controller works. Let's see what description do we have for our controllers. So PID. Last error should be always 0. We don't set it. Current error also we don't set it. Accumulator also we don't set it. So 3 gains and 2 maxes. Okay. So let's assume it will be 5 here. 5 per one, which we have 5, it will be 25. No, 256 parameters is more than enough, actually. And if you need more, like, it's your problem, not mine. At least for now. If it shoots me in the foot, like, in a year or so, like, I will redesign it again. But for now, and also another to do. Allow writing parameters with how do you call with sequential IDs in a single write request? Question mark. Now, this is done. This is done. Request counts. Let's say we have 16 default buffers, 16 default streams with 32 default fields. Actually, 16 also can be default because 32 stream fields is quite a lot. So request count and parameter count will be higher because those are smaller primitives. They are much smaller. Okay. Now, let's fix the MCU side of a description, because now the description will change, because now the master has to know the length of the fields for every type of a primitive. So first of all, this is broken, but let's keep it broken until we fix the conceptual side. And how do I fix the conceptual side? Buffer description code. Read buffer descriptor. Okay, buffer descriptors and buffer values are separate requests now. Okay, and we also have a buffer description, right? Wait, hold on. I think that there should be one more, right? Buffer properties, yes. So in buffer properties, number of buffers, and we also add one more parameter, and this will be U8 question mark. Let's see. It will be U16. Buffer description length. So let's add two more fields that will be zeros by default, of course, because they will be. Oh, hold on a second. No. This is constant, so this value will not change much, if at all, because we are defining them at compile time. Nice. So here, how do we do this? We need to add it here. Let's see, 4 and 5. And we add it like that. Just change the way we do it exactly. I would imagine this is more correct. And we do this here as well. This guarantees that we don't have any weird type conversions, but the definition should be different. It's debug max buffer description length. So now we send it to the master, and let's actually go and fix the master code side by side. So let's open this in our Explorer. Here we are. This was a lot of work I've done off stream to make it a pip installable module that is installed locally, so that we can use this protocol in other projects we work with. But now, let's go in our save all buffers example. And here, when we make a request to read properties, we expect to have 6 values. And at this point, number of registered buffers and also length of buffer description will be struct unpack something h. Let me find a suitable code and just copy it, because I don't want to mess up things like this. Actually, exactly this, just with different numbers. 4 to 6, and this will be here. And this, if we are in a verbose mode, let's speed it out. Let's tell a user how many bytes we expect. And how many do we expect? We expect, so buffers count and buffers description length. And let's put this one in OK blue styling, like that. And what else? What next? We also need to use it lower, because this, instead of reading 32, we will read that. Do we have any this value hard-coded anywhere? We do. This is it. And this value will be now, actually, yes. Where was it? I'm lost. Here. This will be 7 plus this. Anything else? I don't think so. So now what should be... Actually, I think at this point we actually fixed everything. So let's flash this. Let's make sure it builds first. No, we haven't fixed everything. We need to also add it here. But at this point, we upgraded our buffers to be able to store variable lengths from our example, from all other objects, all other primitives. So let's test it. Let's test it first by default, and then we will change the default value and we will see if it works. So let's do it. We don't have any errors, so let's flash our microcontroller, our board. And now that we did, let's run it, and let's go to our Python side. Whenever it is here. And let's do, actually, we also need to connect our, oh my God. Actually, I also need to connect this USB UART dongle, and also connect this to our USB. So, yeah, actually, oh, that's annoying. Actually, let me put it here. I need to make it this cable longer because it's in a way. Okay, so now we are attached mentally and physically. And let's scan our COM ports. And we have our port on COM7. And let's run our COM safe debug buffers on COM7. It worked. And the length is 16. So let's see the file, which is bufferslog 596. This one. Descriptions are saved correctly. And now let's update example to use different lengths. That's different lengths from default one. So to do so, we need to define our values for debug buffers in here. So let's define our debug. Actually, let's copy it. It will be safer because there is no syntax highlighting and syntax autocomplete rather for the way I work with this. So how do we do this? We go into correct file, which is here. We copy this one. We put it into here. We define it, and let's say we want this description to be 24 characters. So let's save, and let's also make sure that we actually send more than 16 just for the test. Array test like this, and this length is 21. this will be 24. And let's do test, ta, 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 and this will be test, ta, ta, like this. So actually this will be more than 24, it will be 25. Actually, this is nice. So let's see if it will, actually, let's see if we will have an error here, because I would imagine, yes, we have an error, that the character is too long. And here then, so it works on the microcontroller side, because we were able to successfully put 24 here, and now let's flash it. And run it, of course. And now let's see what our Python side will tell us. So, or dear Python side, we still are on COM7. Tell me if it worked. It worked. So can you see it on your screen? You can partially. So what is happening is that our reply contains a proper description, and it says the description length is 24. So, and it was 16 before we changed it. So it works, and it works nicely. And let's see the file itself, which is this one, and the descriptions are correct here as well. Very nice. I like it a lot. Okay, so this was actually a very effective, very important, very nice change we've done to debug buffers, and now all our debug primitives will be able to have separate size parameters, so they will be lengths, and they will have different lengths that we can control. Like the default value will be the same, but the actual values are separately controllable, which is incredibly important for what we have tried to achieve. Now then, now that debug buffers are fixed, we can go and get back to work on the re-implementation of our requests and parameters. So let's do it. Now, not yet here. We will come here later. We are working here. Let's add this error, of course, to the protocol side, which is here. So, and this has to be like what? This has to be, actually, I have to add 2 errors, it seems. So let's do it. The main logic will be the same, like this. Debug buffer. Buffer description must not take more than this value. Debug max buffer description length. Okay, you're most likely using too much RAM for your buffer descriptions. Please consider your life choices. Very nice. So this is correct, this is nice, and we can actually do the same for parameters and for requests. And this should be very easy now. So let's do it. Oopsie daisy, not here, rather here. So this will go here. And actually, these primitives are more important. Actually, are they more important now that I'm thinking about it? They are. So buffer is probably, like error log is the most important primitive. It's just opens up so many possibilities to just develop everything. But after this, I would say that requests are the least important primitive. And buffers and streams are probably somewhere close to each other. So let's say it will be buffer buffers related. Boom, bam. Okay. All right. Two more. Okay, okay. This will be buffer, and these are copies, and this will be requests, because requests are... No, this will be parameters, because parameters are more important than requests. Parameters related checks, so minus minus, and one more, and this will be requests related. Requests related error. Boom. Bam. Nice. So debug max parameter description length. Debug parameter description must not take more than this. Boom. And here, the same thing. You most likely use too much RAM for your parameter description. Please consider your life choices. Very nice. Here, not buffers, but requests. Okay, must not take more than this, and we copy this and put it here. Most likely use too much RAM for your request descriptions. Nice. So error checks on the protocol side are done. For now, until I change my mind and come up with some other ideas to redesign everything, of course. Here, we can remove these to-dos. They are not anymore needed. What else? What else? What else? Now we can come and start implementing. We actually, you know what? Let me do some beautification here. Okay. So error log and debug request is not as important, but maybe it is. It is a part of this, right? So it might as well go here, right here, because this is currently a mess. It's a complete mess. And this has to go to a different place. Okay. Okay, this is important. Love it. Actually. So now, what do we do? We move the camera down to see the code better. And let's see. So we were working on parameters and requests. And we have request and request pool and parameter. And parameters will have a description, of course, which must use a parameter description length. Be para with the description length. But parameters will also have type. So parameters have to have a type. And the type for them will be stored as your int8. Int8 t parameter type, and also it will be a constant. And this will be a const as well. Or will it actually? Will there be a reason at any point for us to have dynamically allocated parameters? Let's think. What can happen in the world that we may need to use a dynamically changeable parameter name and parameter type? I don't think there are situations like this, but also I'm not entirely sure. I'm not entirely sure I want to make this as const as well. Or should I just make it as const? Because why wouldn't I, right? Are there situations when I would like to populate my description of the device in software instead of in at compile time? Okay, I don't know for now, but the safest bet is to not use const, because const can be added at any point and it will change almost nothing. But removing const can be problematic in the future. Or will it actually be problematic? Whatever. Whatever. Let's not have a const here for now. Do we need anything else for the parameter? Then amount of bytes we expect for the parameter will be determined by its type. So we are not in troubles here. And the description will tell master what the parameter do, so the master can decide what to send. Do we need anything else? IDs will be stored as a position in the as a position in the pool. So ID will be positioned in the pool. And it can be automated on both master and slave side, so we don't need to store it, because storing ID is a waste of memory, and we don't have much memory, so we need to try to organize this as neatly as possible. I think it is for now, but it's all. So let's make a parameter pool then. Type def struct debug parameter pool. Okay. And the pool will look as any other pool looks, which is our car. Hold on a second. And it is not how it looks. This is how it's supposed to look. And also we have to add our debug. Debug parameter pointers. So we need to store them somehow in an effective way. So debug parameter pointers, and it will be parameters. And we will have a debug max parameter count. Very, very nice. So the pool is ready. Now we need to update our registration function. So we need to update the way we register parameters, because before this, we didn't have a registration option, and therefore we didn't have an option to read parameters. And now we need to add both, which will complicate the write parameter example quite a bit, but will give us an incredible amount of control, an incredible level of control. So let's do it. And now. Let's see, one moment. Back streams related checks, debug buffers related checks, and we will have to add checks for parameters and for requests as well. So let's do it. And debug parameters are more important. Oh my god. Parameters related and request related requests related things. So let's clean it up. Bow, bow, bow. Here, we need to add similar types of checks, just with different naming. So we don't have fields, so it will be only a single check here for all of those body streams. And the check will be like that. Must be below 255 due to UA type used to index parameters. Okay. And here, similar thing for requests. Okay. And index requests. Very, very nice. So checks are added. We are checking for user errors and for user being a dumbass. Now, we need to add registration procedure. And that's all, because the cleaning procedure will be on in developer side of things. It will not be on the debug side of things. So then, to keep the same styling as everywhere. Oh my god. Oh my god. Now let's add this separator. Everywhere. And now we also error log related functions. Sure. Here are okay. Debug at value to the buffer, register buffer, clear buffers. Okay. We will have a change for streams. Sure. ITF queue message, update message queue, and update com stream. So these are related to not primitives, but rather to general protocol. So they should be on top. And this should be a king because this is actually a separate function completely, because it just kills the device safely. Okay. So protocol, buffers, streams, and here let's work on request or parameters first. Let's work on parameters first because parameters are more fun. So let's do it. Debug parameters functions. I don't think the word common is applicable any longer, given that we changed a lot of things. Debug buffers functions. Okay, here we need to be able to register a buffer, a parameter. Debug ITF register parameter, and this should have a protocol and a parameter as inputs and parameter pointer, of course. And this will be debug parameter. He'll be parameter ptr, and this should also have buffer ptr. So this as well. So this is also ptr. So anyways, void also debug ITF clear registry. Actually clear, now that we changed the name of the structure to pools instead of registries, let's actually change the this function as well to be debug clear buffers pool. And that means that we will also need to change this to be, this should be renamed, of course, to do rename, but we haven't gotten to streams yet. So pool, and let's change it in C because we have a registry somewhere here. It is actually exactly here. And we add pool here. Let's build and see if it builds. It will not build because of this, but let's see if we have any other issues but that. Let's see. No issues, it seems. Yes, so we can continue. So clear parameter meters pool. And the clear of the pool will be a protocol related thing. So protocol. Nice. Now let's copy this, go to here, add it here, and let's implement them. So what do we have here? This will be incredibly easy. It will be protocol dot oh no, we forgot one thing. I forgot rather, not you, my dear viewer. Here in protocol, we now also need to store other pools as well. So we will store a debug parameters pool, and also request pool. Oh, everything streams, buffers, parameters. So I need to change the parameters. Okay. Parameters pool and requests pool will be requests. Requests pool. Okay, so now our main struct that controls our protocol, whatever it is, no matter it's UART, USB, or whatever, it's updated. I have a new YouTube subscriber. Thank you, whoever subscribed to YouTube. I appreciate it a lot. Now, and also I appreciate follows if anyone wants to follow. Just saying. No pressure, no pressure. Here, so this will be easy. Protocols, it will be a parameter pool, and we just set the index to 0. This is the whole function. Very nice. And this will be more complicated. So here, what do we do about it? We need to register parameter. So let's do auto registration functions as a guide for ourselves. So let's copy it, paste it here, and let's see. So by the end of it, if everything is all right at this point, what we need to do is we need to do our parameters pool. We increase the index, and we also parameters pools next index. We use a parameter pointer. So we save it into our pool, and now it's available in the pool. Now we need to check everything as well. How do we check everything else? So we can do error checks. Let's see. So we work with parameters pool this time. So next to the index should be max parameters count. So this should pass, and I need to use another substitute of errors. Too many parameters are already registered. Sure, this is an error we log. Then if the parameter pointer is null, we have a problem that we don't want to have, of course. So we log this error. So user provided null pointer. Sure. So now, shall we shall check the structure of our parameter itself. So let's see what our parameter holds. It holds 2 fields only. It's much simpler than both streams and buffers, so it will be a very easy check. Let's see. So can we check description? We cannot really, and description that is empty, that has nothing in it, is not a problem, and description cannot be a null pointer because it is not a pointer at all. It is a part of a structure, so we don't need to check description. So the only thing we actually need to check for a parameter is the parameter type. And let's see. If parameter, actually we already have this check. Let's just update it then. So parameter pointer type is outside our boundaries. Let's use type, just type. Why do I need to specify the parameter type? What do we have for our requests? Do we have the same issue there? Oh, for requests, we just don't have a type. So type, bump the error. We don't have size, so we can remove this. And we don't have any values, so we can remove this as well. And do we need to check if the parameter is already registered? I'd say we do. I'd say this is rather important. So let's also, only when we are in debug mode, because it's kind of performance heavy, especially if we register many parameters. Like the more parameters we register, the heavier the performance here is. So let's check it then. We go into parameters pool, and we iterate through all the components that are already in the pool. And if our, let's put 6 here, if our parameters is already present, we will have an error because parameter is already registered. And this will be a problem because, oh, hold on a second. Wait a minute. Hold on a second. Actually, I think, now thinking about it, I think I need to store the ID of the parameter if I want to work like this. Oh, hold on a second. I got a bit ahead of myself. Hold on a second. Do we need to store a parameter ID? Because how will the master address the parameter? How will the master say, like, set speed to something? It will sell, not sell, but send the ID. Oh, but we have our protocol, and we will address it in the protocol, and that's why. Okay. So it is possible. We don't need to store an ID because ID is already stored in the protocol itself, because the protocol stores a pool, and the pool is in an array. And an array we can index by the ID. So this is solvable. Okay, so we don't need to store an ID. So where were we? We were at our, hello? Here. No, we were here. At our register parameter, which is, where are we? Parameter here. So let's check it. Parameter pool, errors have correct error codes. And if everything is correct, we just add parameter to the pool and we are happy. So this part is actually finished. So we are finished on the debug side of things. Now we need to work on the protocol side of things. So how will we do it on the protocol side of things? The same way we do it for buffers. So let's go there and let's do it. Let's go to our protocol. And our protocol will need to handle multiple things. So first we need to change codes. These codes are still work in progress because we are changing everything. So we can use these codes. So let's define debug interface, and this will be read parameters properties. Let's params, let's make it a bit shorter. It's kinda too long. Kinda a bit too long. And let's start it from 2 so that we have, and in case I change my mind again, we have a headroom of like 14 codes here to work with, because we have more than enough space, like code space, to be able to do it like this. Now, we will also need to use parameters. Now thinking about it, would it make sense for us to just send all parameters descriptors right away? No, it will not make sense because, yes, because it will be outside of our protocol and it will break all the rules we specified before this. So let's actually force the master to request a description of the parameter for every parameter. It will be annoying because some messages will be very small, but it will be correct in the protocol way. Because otherwise we will force a master to read all the parameters. And otherwise we will not support properly a workflow where parameters can be registered at runtime, and the master would like to check if the new parameters were registered and read only new registered parameters. So this workflow will be broken if we will send all the descriptors right away. So we will have a separate descriptor code to support this workflow. So param descriptor code, and then it will be ITF write, because it is parameters are written, not read. So write param value code. So parameters are written, and now we need to implement it inside the protocol itself. So let's do it. And our protocol is in RC file in a very long function. So here it is, and buffer values, and this is if the buffer is a ring buffer. Very nice, it's kind of a nice solution. So here we will add our code for these boys, and currently this is gonna be gone, but for now we will keep it for future reference. So we need to add 3 functions that will have a similar structure to the functions of the buffers. So let's actually copy buffer function and change them. It will be an easier workflow to follow. So read buffer descriptor and read buffer properties. So this will all be copied and updated. Now, one at a time, of course. Now that we added here, we need to add more predefined messages, of course, for our parameters. Let's see. Buffer properties and buffer description. It should be buffers properties. And this will break a code. So let's see where it's broken. It's broken here. Easy fix. Easy fix. And here and here. So it's fixed. It will be broken here, but we will change this part. So let's go and copy this one, because we will have a very similar approach, and it also makes the protocol much easier to extend, to work with, to use, because every single primitive of the protocol has the same handling. So it's very nice actually. So message parameters properties, and also message parameter description. Here properties should be 6, a number of parameters of registered parameters, and this is of registered buffers. This is very important. And a parameter description length. So this will still be a 6 value, and let's close this and let's implement protocol 1 request at a time. This will be much more manageable. So let's remove this for now. And let's see, message parameters properties. We add protocol parameter pool. Oh my god, parameter pool. Next 3 index. This is how many we have added. Sure. Hello, Mr. Das. Welcome, welcome. How are you doing? And that is here, and here we will have a max parameter param description length, like this. We good. What about me? I actually my move to Germany for a month was accelerated, so I will have to leave on Sunday early morning. So I spent my whole day preparing. I was booking my tickets, looking up like apps what I need to use, finding out like I need to buy a suitcase because I don't have like a small suitcase for planes. I only had like a huge one for buses. So I spent all my time today, almost all my time today, preparing for my trip for like a month in Germany. So here we will send this message and the ciphers of this message as well. But I think the progress is going nicely, and I hope I will enjoy my time in Germany. But yes, streams. Tomorrow will be the last stream for me for a month. So tomorrow we will actually do fun things on stream. We will play music on the modders. And I think I will try to prepare so that people can request a song and I can like convert it into notes that modder will play. So that like if people would like to join tomorrow on stream, we will play modern music, but I'm not sure how many people will join, and maybe it will be like a complete mess. But we will see. We'll see. Like how much time do I have to prepare tomorrow? Because today I have no time to prepare for stream, like unfortunately. But it happens. Life happens to everyone, I would imagine. Now this part is implemented, so let's go to our Python side. So guys, if anyone here want to visit tomorrow's streams, please follow to not miss it, to be able to play your songs, requested songs tomorrow. Okay, now we are in the protocol side on our Python side. What do we need to do here? Let's clear our console for now. And let's see, save all buffers. Do I even have a function to do it right now? I don't think I do. Right? Save stream data. No. What else do we have here? Send generic request. No. And send parameter write request. Yes, but this is only part of it. Nyancat 10 hours allowed. Nyancat is allowed, but 10 hours, I don't know. I'm not sure. I will think about it. But yes, I'm old enough to understand the Nyancat 10 hours reference. Okay, so here, let's add a function. Def read param properties. It will be a very simple one. So it will take a serial port. What else? It doesn't need a param type or param value, and it's only needs if it's is verbose. So how will the function look? We will use this. Let's see. Also on the MCU side, do we acknowledge a request? No, we don't acknowledge the request. We just send the description right away. This is actually confusing because there are requests that we acknowledge and this request we don't acknowledge. Actually, I need to add to do. So to do, should I acknowledge this request or rather remove AX from other requests? I'll think about it later. I think it's not the time for me to think about it. So if device is not connected for this function, okay, wallet types. This is not needed. Here, some message. And we also need to add a request message to our Python side as well. So the message will be as following. Message read parameters description. Right? Does that make sense? No, it doesn't. Properties. properties. Parameters. Parameters, okay. So it will be a byte array, of course, of our message prefix, brother prefix plus what? 0 x to 0. If I remember correctly, let's see here. Let's see here. And this is buffers and this is parameters. So, oh no. Oh yes, I just forgot to change this. Okay. Now, parameters properties, which is 0.2.0. Okay, so we have this message to work with. And let's actually go here and use this as our base. Do we need to do anything else? The request itself will be only 3 bytes, so we don't need to append anything. Like, this is a whole request, and we just need to send it. We send this request right away, correct? We write it and we read the reply. And the reply we expect to receive shall be 7 or 6. Let me remember correctly. It should be 6. So we expect 6 bytes back. So let's read 6 bytes. And now we need to make sense of these 6 bytes. So let's continue copy pasting our own code, of course, because this is the way. This is the way. Actually, we don't need this. Actually, let's copy paste our code from a better source, and our better source is our buffers communication. So let's go to our buffers communication, and our buffers communication is here, I would imagine. No, it is here, I would imagine. Yes. So here at some point we also read 6, and here we can do all the error checks and we can save this. It's an easy copy pasting from ourselves to not type too much, of course. And just not to get lost in the source, let's close this function. It's annoying. Let's close this as well. Here, we've read 6 bytes, and if we didn't receive 6, we are failures. So, run response to read parameters properties. Okay, wrong answer length is correct. Next, if we didn't receive a proper prefix, and this shouldn't be here because, oh no, it should be here, but it should use this message instead. Okay, wrong response to read buffer properties, to read parameters properties. Okay, now number of register parameters. Okay, this is it, and length of parameters description. Parameter description is as following. This can be used as the same. So parameters count and parameter description length. Should it be capital or lower? Sure, let's use capital. Why not? Or was it? It was capital. Okay, whatever. And length of parameter description. So actually this will also already work. So let's return at this point. And to do continue. And we can actually now register parameters in our main and try it. So let's try the first call to our protocol. So this is our motor descriptor. Let's go and create some parameters, shall we? So debug parameter. Let's say it will be like speed param, and this will be equals to description of, let's say, speed, and the type will be f32 type. So this is a correct way to create parameters in our approach. And let's do a few more. So let's say we will also have like position, and it will be position, and it will be of type E64. And this parameter, let's say, will be our, what can we use to use a different data type? A different data type. Let's say ADC raw something param, and it will be ADC raw, and this will be U16. So we have 3 parameters that don't have a value here because they are mapped directly onto, like, the way they are mapped on in our code will be determined by the user of a code, by the developer rather, not by the protocol itself. So protocol must not in any way be related to how the handling is happening on the firmware side. Now that we've done it, let's register them. So we need to go and debug ITF register parameter. We have only one protocol and we need to register all of them. So we have a position param, which will have ID 1. We have a speed param, and we will have a ADC something param. Very nice. So at this point, they're supposed to be registered, and if everything is correct, we will be able to call this from Python. So let's flash it. And let's see if it works. Let's see if it works. Okay. So let's run it and let's go to our Python side. Let's see. Let me move my motor to the top right corner temporarily. So Python scan COM ports first. We are at COM7 still. And now, actually, we don't have an example that what will I even call here? We haven't prepared anything. Okay, so let's see. Example. How did I call it in a new style? Example com read param properties.py. So this example will be incredibly simple. So let's actually copy. This will be quite a copy actually. Let's copy everything and clean as we go. And this example, let's move it to examples right away actually. Let's move it to examples because we design it in the correct way. So all the description actually, most of it actually will be useful. So do we need all of it? I'm not sure, but let's keep it for now. Com, bot, and prefix are default for everything, but we don't need a prefix here. So prefix can go. No offense, of course. But com and baud rate are important and are usable. So then this stays, this code is as always, and result. Actually, we will just simply call a single function. Actually, it will be CDP, and this will be I don't remember the name actually. What was the name? Read param properties. Okay, read param properties. And we need to provide serial port, which is our serial port, of course. And we also need to provide if it is verbose, and let's say true, because we would like to see that it works. And now let's call our cd examples, and let's call our Python, just not in capitals. And this will be example com read param. And of course, I forgot to provide the serial port. So let's fix this issue. Wrong response to read parameters properties request. Okay, so we have an issue temporarily. Let's fix it. And wrong response. It's not here. to read parameters. So wrong response to read parameters properties. Okay. Let's for x in device reply. Let's print hex of x, and let's end this with a space, and then we'll print just a new line. So let's do it. Did I save it? I did. Wrong response to read parameters request. Actually, wrong answer content. Oh, okay. It's wrong content, not this. Okay, I am a dumbass. So we have a correct number of bytes we received. I'm stupid. So wrong answer content. So this read parameters properties, and this should be 20, x20. And what have we done here? Did we do a correct creation of our messages? Let's see, let's check. And buffer properties. No, of course we did not, because I'm stupid. Haha. Read parameters properties. Okay. Okay, sure. Whatever. And let's fix this right away. So now let's refresh it, and it should work fine. So we are here. We flashed. Let's run, and let's go to our Python side. Let's clear our mess. Let's check that we are okay. Can I do it like this? Yes, like this. I can. Okay, nice. Very nice. So, and let's do this. And we have 3 registered parameters with description of 16. Yes, sir. Very nice. Perfect. So it works. So first part of our protocol for parameters works. And we have 2 more parts to go. And I need a short break. 1 minute, maybe 2 minutes. We'll be right back. Look at the motor for now. I'm back. So now we need to implement 2 more things. Let's do this. So the first thing we need to implement will be the, let me switch to my IDE, of course, is message read parameter. This will be descriptor. Okay, it will be byte array of message prefix plus 0.x to 1. Very nice, very nice. But now thinking about it, I actually think that this should return a value that we can use. So this function should actually have a return value. Where is it? Where is it? Here. So this function has to have a return parameter that will be, it has to have two return parameters actually. So let me see how to do two return parameters, just by copy pasting from myself, of course. I think I can return a tuple, but let's see. I just return a tuple. Okay, sure. I thought I will have a specification of a return time here, but I don't. So we might as well just do it as it will not continue. Actually, it will be a standalone function. And we will have a tuple return, and the tuple will contain both the number of registered parameters and the description length, because we will need to use this in other functions. So let's return a tuple. Very nice. Now let's define a function that will be called as read param descriptor. So this function will, of course, take serial port, but it will also take target ID, which will be int, and it will also take param description length, which will be int as well, and it will also take a bool if it is verbose with false by default. So what will this function do and how will it function? So this function will create, of course, a request. And let's not repeat our errors from 2 days ago. Let's actually add here a new field. So it will actually need one more that will store an ID of the parameter we would like to get the description of. So here, this request will be a 4-byter, and 4-byter arbeiten. Here it will be read param parameter descriptor, and also message of 3, which is our last byte, will be equal to target ID. Now, we write this message to the serial port and we expect a reply with a length of 7, and we need to handle the reply properties like this. Copy paste, of course, here, 7 here. Actually establish for param. Let's make sure that our error codes make sense. Parameter descriptor for parameter, and let's put a parameter number, target ID, and let's make it, oh, it will already be colored. So wrong response for parameter read descriptor, to read parameter descriptor for parameter this, read wrong response to read parameter descriptor request for parameter. This reads better. So let's parameter descriptor request for parameter wrong transparent, wrong content, and this should also be that. Okay, and here at this point we need to do something with the parameter descriptor. Okay, now before we implement this, before we work with this, let's go to RC side and implement RC side. So let's switch here, remove unnecessary pieces, move the motor around, and let's see. Actually, should I keep the motor on top? Nah. Should I keep the motor on the bottom right? Is it better? Actually, I think it is because it doesn't cover as a console then. I think I should have done this all the time, actually. Okay, a new position for the motor cam. Bottom right. Now, let's uncomment this one. And now let's think about it. Let's not. Thinking is for the weak, of course. So it will be param ID, parameter ID rather, parameter type, and parameter size is not needed, right? We only will have parameter ID and parameter type. We will not have anything else. So this can actually be 2 bytes shorter. And this will make it a 5-byter. Now, with this being done, let's go and implement it, of course. So, here, let's uncomment this part. Here, let's put a proper code, of course, and the message length is supposed to be 4. And if it's not 4, we have an error. And let's say this error will be offset. And we, like here, I sent another acknowledgement, but here I just don't even check anything. Okay, this is not important now. For now, what's important is to just make it work, and then I will make it beautiful. Now, target ID will be a 3, correct. It shall not be 0 because we have a numeration from 1. Right, and this is correct. So, log error, let's offset by 1. We not acknowledge. Okay. And then we acknowledge if this is correct. So this is not needed. So this is gone. What is the size actually? Where do I have the size? Oh, this is the size. This will be completely gone. Target ID, we reply with what we got. And we get a parameter pool here. Parameter pool. And parameters of target ID -1 type. Nice. So we added this to the message, of course. And what do we do with this message is we just queue it, right? Message buffer description, message. Hold on a second. Oh, of course, it should be a parameter description here. And actually, I interchange parameter description and descriptor, and I think this should be a descriptor. So let's save this, and let's use refactor, rename, parameter descriptor. And let's do the same here. Refactor, rename, parameter descriptor. This will be better because it's consistent with what we have on the Python side and with the meaning of what we're trying to achieve here. So let's add it here. Let's put it here and here. Then we have a message pointer that is from our parameter pool, of course, parameters and description, and this goes to our queue with a proper max parameter description length. Because this is description, because description is a string that describes the value, and descriptor is the parameters of the parameter, so if it makes sense. So the descriptions here is correct, but descriptor here is correct. So to not confuse anyone, we fixed this, so this side is finished. And we can go and implement the Python side. So let's do it. Let's implement the Python side. Here, we expect to read 5, not 7. Not 7 given our changes. Here. What shall we do here? We copy paste, of course, from ourselves. From ourselves in the past. Can I do this actually like this? And I would, oh my god. This, and I would like to request a double and like here. So for ease of copy pasting, of course. Here, let's find how we handled buffers. Read all buffers. So at this point, oh, we will need this part. Oof. This part is rough. Okay, we will actually need all of it. Okay. Yep. Seems to be correct. So let's do it. Let's go here. And paste this in. Fix the tabulation, of course, by 1 shift. And here, record type. So this will be a parameter type. Parameter type. Where did I put it? No, it's correct. What is this then? This is not needed, right? I think so. I think this is not needed because... Hold on a second. Let's actually open our sys code and see target ID. So 3 is ID, and we can actually check it here. Or actually, can I do it like this? Does Python work like this? It doesn't? Oh no. What do I do now? Whatever. Then force is, let's remove this line. So third is ID and force is the type. So this is the type and record size is default and flag type is default. So let's do it here. And we go through to the parameter size. Let's just do it like that. Boom, bam, bam, boom. No! Oh no! Parameter size. Boom, bam, bam, boom, bam, boom, bam. Nope. Let me get back here. And unpack type is correct. So we match for parameter type. Then value. Okay, and case. Parameter of I of target ID has unknown type, record type, aborting. Okay. So we give parameter, and do we give anything else here? No, we only get the type. So here this is not important, and parameter description. will be was. Oh, I see what this is, but it is not correct here. So parameter description equals to device reply. It will be 5 to length of buffer description, but we should use length of. This shall be removed, and this shall be used. Like that. Decode and remove, and this is parameter. What? Why is it says size? Oh, it says size, right, but type. Parameter. What? What is happening actually? Hold on a second. Unknown record type, but record type is. Oh, okay, whatever. Sure, and this will be parameter type then. Okay. Now, description, and we need to print it out. How do we do this correctly? Is verbose parameter target ID record type. It will be just type, and the type will be parameter type. Yeah, very nice. And then this is not important. We only have description, and this should be a comma separated. Over here, make sure that we have a space here. We do. So then out after comma, we do description, and we just do parameter description here. And we need to return something. Like, what do we need to return? I'm not sure for now. But we definitely need to return something here. So this can go. And now we are ready on both sides, and we need to prepare the example. So let's make an example that will do what? So let's say new file, example, read all parameters.py. So let's start like this. And here, this will need to be changed. Sorry, to do. Update description. Same here, actually. But not today. Maybe today, but off stream. Who knows? Who knows? So we go here. We drink some water. And we do what exactly? So we use this and that. Of course, sure, whatever. And we need to print every single parameter we have. So we establish connection, and let's create values that we will store our returns in. Let's see what order do we return things in. And the order of returns is what is it? Number of register parameters and length. So it will be param count, and it will be param description length equals to this. So here, for I in range of param count, let's do a CTP read param descriptor, and we provide our serial port. Then we provide our I +1, and then we provide description length, which is param description length, and verbose is true. So this should work if I'm not a dumbass, but as we've proven many times on this stream, I am a dumbass, so no promises here. So this shall work. Let's make sure that our C part builds without errors. It does. Let's flash it. And we have 3 parameters installed. So our Python has to read 3 parameters and their descriptions and print it into the console if I've done everything correctly. So let's run the code. Let's switch back to Python. We are in examples, so let's make sure we have it here. Let's read our serial ports. We are still at port 7. And now the moment of truth, of course, it's Python example com read all parameters, param properties. Hold on a second. What do I supposed to run actually? Why are the names so confusing? Oh yes, I has to run this and I has to provide com, of course, com7, and it didn't work. And it didn't work. Why? Run response to read parameter descriptor and device is not connection established because it died here. Let's see. It should be very easy to debug, it seems. So let's see. So wrong response to read parameters descriptor. Wrong response because I probably forgot to update what I supposed to update, right? Not again. Let's see. So the return message for 21 was what? Read parameter description, which is 21. It's actually not 21, it's 33, but it's hex 21. So this is an expected code, of course. And in the implementation, we have target ID on 3, which is correct. It's force position, and also protocol type at 4, which is also correct location. So probably the issue is in Python side then. Actually, let's see if we are in debug mode. We are in debug mode. Let's see if we have any errors on our C side. We don't. This is a reset error. So this means that the error is most likely on the Python side. So let's actually see what is wrong on our Python side. So here, message prefix should be correct. It should be 5. It was 5. It says that parameter description request. Parameter 1, wrong answer content. So read parameter descriptor. And parameter descriptor shall return 21 here. So this is correct then. Was. So the answer was correct then, wasn't it? Let's see. For x in device reply, print x hex dot x of and equals to space print just. Let's run it again. Okay, this should be hex with small letter, of course. Clear, and do it again. And the message was, oh, very interesting. Okay, this is confusing. Okay, interesting. So we got an acknowledgement. And then, oh, of course, because I sent an acknowledgement. Of course, I forgot to handle the acknowledgement here. I am stupid. Oh my god. So the return here should be an acknowledgement first. So it should be acknowledgement and then a parameter sent right after without any break. So I'm just okay. This is easy to fix. I'm just not following my own protocol. You know how it happens, right? Okay, so let's actually just copy paste our own handling of this exact situation from our own code. So what is it? Save all buffers, and at this point we need to send something, and we read 3, something 3, and then we read again. Sure, so this is the code, the correct code, so let's put it into correct place. And I actually think I just need to make it into a function because I just copy pasting the same thing and just change the error code actually. I think I have a pretty functional defining code. I program in Python as if I'm a junior. Oopsie daisy, whatever. I do what I want, you know? So, read 3. Let's see. Let's see. Where shall we put it? We shall put it into not here. And also not here. Where the hell are we, actually? What? Where are they? And what is param? Oh my god. Param descriptor. So here we shall edit the properties, or rather acknowledgement first. Okay, to what? To param descriptor read request for param target ID. Yeah. Now, target decline param descriptor read request for param I. This. Sure. Now this shall work. So it's clear. Let's run. And okay, I changed the name of the function, of course, and I broke 2 examples because of this. Happens to the best of us. Param properties. Actually, no, I only broke 1 example. No, I broke 2. I'm joking. I broke 2. I broke 2. I fixed 2. So let's see. Okay, so it's read. It's read first parameter correctly, but it didn't read the description correctly. Oh, hold on a second. Something is wrong, and also on the Python side. It is definitely a Python side issue, I think. Python declined param descriptor read request for param2. Okay, but we also haven't saved the description. Do we have description in C? Let's see. We do. We have a position as description here. So it shall have been sent. Should have been sent, and this means that it should have been here. Param description length, which is int, which is inputted as wrong example. Move it to this side. I+1 param description length. Is this correct return order? Yes, it is. Just for my sanity, before we do this, let's just print param description length. So let's do it. It's 16, so it is correct then. So the issue is inside this function then. Do we properly handle device reply of this? Do we expect a proper reply length? No, we don't. We do not. I am stupid. I am stupid again. So this is the length we expect actually. And now it should work. Now it works. Very nice. Very, very nice. Hooray! So we are one step closer to our debug protocol being able to send description of everything that is registered, and for Python to automatically be able to not care about what exactly is on the device and still work, still being able to communicate no matter what device is. But we are not there yet. We have one more function to implement, which is parameter write. And we also have, oh, we have so much work actually, still. The amount of work is measurable. Uh-oh. Okay, now think about it. What shall we return? And return is actually now very simple. So parameters has only two values that are important. So we will return a parameter type. And also we don't care for parameter size at these points. So we can just simply remove all of it.
Troika76 is now following.
Thank you, Troika76, for following. I appreciate it a lot. So I do believe that we don't care about any of it in this function. And it should still work. It still does work. Very nice. And now we return the parameter type and we return the parameter description. So tuples all the way. So one more function to implement then for today before I fall off asleep. Okay. So, and the function will be actually, I don't think this function is useful because they have very different philosophies. And the function we will actually use will be this function. So let's copy it up. Let's copy it up and change it up as well. Like here. So, first of all, we need to use a correct code, which is this one. Here. When we, oh, my camera broke. 1 moment. Camera work. Nice. Okay. So, this is the correct code. And now what do we expect? What is our expectation? Our expectation is that the master will send us the ID of the parameter it wants to send, the type that master expects the parameter is, and then the parameter itself, right? So 6 here, is it correct? So it will be prefix with 2, then index that is, no, then code that is 3, then index that is 4, then type that is 5, and at least 1. So this is correct. So the smallest message here shall be 6, but the biggest can be 9. Oh, not even 9, but 13, because we can send you 64 parameters. So with this in mind, this code will stay. And this message non-acknowledgement is correct, and this acknowledgement message is correct. And actually, this works completely. I actually don't think I need to change anything here but this code, right? And after this, we send our parameter ID, parameter type, and the reminder of the message to our handling function, right? And the handling function shall be very fast. It shall handle the parameter very fast. So I think how it's supposed to work. And we also already have an example on, it will actually be so nice. This will be so easy, actually. But, so let's actually redesign the function we have as an example, because we will still need to store it as an example after all, after we finish. So let's do it. And the function is here, this one. But now, for this to work, we need to register all these parameters. So let's copy this. And this code will also change, but not super significantly. Let's just think about it and let's just do it nicely. So how will we do it? Actually, at this point, we can break something. Let me think. No, let's not think. Let's break it, and if it's broken, we will fix it. And if it's not broken, I'm a good boy. So we need to define all these parameters and register them. So let's see. This will take a while. Okay. So our first parameter will be float param oopsie daisy, and this will be part of the description. Is it short enough? It is short enough. It is 15. And let's just do it like 7 times. And here we will have I param. Let's actually call it F32. Like this. And this should also be F32 then. And we go here. Like that, and like this, and this should be I. Oh, that will take a while. Oh no. U32. And here and here. And let's keep going. We take this with us for reference. And let's remove this to save space. So the next one is I16. I16 param. And here we have I16 type. Nice. Then U16 param. Mama just killed a man with a gun against his head. Now he's dead. And here and here and there. This is done, and 2 more. 2 more. Yeah. Oops. What? Yeah. Oh, my camera is dying again. Stop. So here. And the last one. So this can go away. Right. I, U, F, I, 64. And here we have U64. And this will be a U64. 64 param. So these parameters can go for now. They are not needed. And let's do the registration of all our parameters, which is a lot of them. FIU Also be CPK F32 param. It will be CPK I32 param. It will be CPK U32 param, and we need like 3 of them. It will be 16, and also why is style different here? Okay, it will be U8, and we also have I64 and U64. And this is unnecessary, and let's just flash it and test that this works before we implement the handling itself. We have an error, not a big deal, and no, please don't F me. Thank you very much. That was an accident. Okay, let's flash it. And see. And let's run it. And let's go to our Python side. So Python, I think I just... Okay, very interesting. So it worked for 3 of them, but it didn't work for the rest of them. Why? It says correct number and correct description length. Target declined. Okay. Target declined. Interesting. Let's see. Let's see what's going on. Why are we declining anything actually? Because we have... Actually, let's see if we have any errors on our C side. Let's see if we have any errors here. Okay. Oh, we do have errors. Okay. Very interesting. Very interesting. And what are the errors? And the error is master requested ID that is not registered. Okay. Very interesting. It requested it twice. But let's keep investigating. What is our protocol status right now? So our protocol has to have 8 parameters registered, right? Let's see. Our parameters pool, it has 8 of them registered, and the pointers are filled, so they are registered. And the next ID is correct. So what happened? Like, actually, is the issue on the Python side again? I would imagine so, because my Python sucks. Okay, so for I in range, I plus 1. Let's print I just in case. 3, and it's declined for parameter 4. It's declined for parameter 4. But first 3 are read. What? Why F32 here? Did I register them incorrectly? Oh, I did, actually. Uh-oh. But anyways, that was not an error that breaks stuff, right? So ID numbers are correct. Let's see if they are target ID. So let's print message of 3. And it is still correct. So da-da-dum, da-da-dum. Actually, how many errors do we have? 2 more. And how many times did I run the Python script? Twice or once? Let's see. I run it again. 1. So we have 1 error per Python run. So probably it doesn't like 8's ID. But why does it decline? If it doesn't like this, why it is declining? Let's see. At this point, let's put a breakpoint and let's run Python again. We are here and let's see what the target ID is. The target ID is 4. Oh, because I'm stupid. Because it's a buffer pool. Okay, I'm a dumbass. Okay. Uh-oh. Oops, I did it again. Da-da-da-da-da. Okay, now it's fixed. Hopefully. I hope so. Let's see. Let's clear our console. Let's scan comports just for the good sanity check. We did, and now it reads everything. Let's remove unnecessary print. And where did I put it? Let's remove this. And also, where was the print line that I've added? I don't, oh my god, I will never find it. Print a message. Oh no. Oh no. Okay. Where was the print I've added? How do I fix? Oh, it's fixed. Okay, sure. So this works. So we see all parameters and all descriptions now. Oh, very nice. And now we shall do what? We shall... Actually, I think about a complicated example. What I'm thinking about now is that given that we know the types of the parameters and their IDs, we can make an example that will be a bring up example. It will be very useful in the future that the Python script, no matter how many parameters are registered, will send a value to all the parameters, like correct value given the type, and correct and different number. For example, for the first float parameter, it will send 1. For the second one, it will send 2, and so forth. And this will be needed to see if the master provided descriptor and master provided handling are correct. But for now, I think it's just a bit too much work. I just needed to note it for myself in to do, but we will do a simpler example first. So let me add a to-do somewhere here. Implement an example of write parameter that will send a unique value for every single parameter. Use index 0, bump it for every parameter, and use a unique formula for each parameter type. Let's say index multiplied by 0.25 for floats, etc. Will it be nice? I actually think there may be overlaps. there may be actually to not have overlaps with floats. I just need to use a number that is we can't have like genuinely, oh my god, I forgot the word, genuinely, like what is square root of 2? What is the type of number it is? There are integers. Oh my god, I don't remember. Am I stupid? Let me Google types of numbers. Irrational, yes, that's what I meant. So here actually use irrational. We can't have actually irrational numbers in microcontrollers because we have limited memory. But like if we use something like sqrt of 2, we will never have an overlap with any other parameter. So it will never be integer value because we try to use an irrational value here. And the point of it is to try to make sure that every parameter is different so that we can see it on the slave side that this is tested. I'm too tired, man. Okay. Let's finish this for today. We can do it. So now I will do a blind write parameters because it's just easy. So this function will go send param write request. Yes, you. And what you will do is parameter ID, parameter type, parameter value. Okay, thanks Python that you don't need an input type or I would have died. With a stroke, of course. So, device connection. Good night, Mr. Das. Thank you for being here. Sorry if I was too boring today. You didn't type much. I appreciate you being here a lot. Good night. See you tomorrow, hopefully. Or in a month. Okay. So, parameter type. I'll try to join tomorrow, but not sure yet when I'll be back from work. I see. No worries at all. No worries. Thank you for supporting me at all. Genuinely. I really appreciate it. So, param type. This. I was working on my own stuff, so didn't type much, but you were not boring. Thank you. And what type are you working on? Do you have some personal projects as well? Tell me more before you go to sleep. Okay. Or were you enjoying? It's nice to have your stream open. It helps to focus too. I think I need to do like this like work with me type of stream. Okay, so I am your second monitor streamer, I see. It's a pleasure. Okay, so sure. Then byte array struct pack. Okay. And this is a correct way to do it. Sure. Send parameter write request. So this is correct then. So what do I need? I actually don't think I need to change anything here, actually. Same for me. I'm debugging an 16 by 2 LCD driver for the Raspberry Pi Pico while I lurk. Sure. I appreciate anyone here in the same capacity. No, it was actually for my job. We were having our next prototype being delivered soon, so I have to finish some new features for the board bring up and testing since there is a lot of time pressure from management. I see. Damn management! But I get it. Good job doing this. You got it. I believe in you. So, good night. Good night and see you next time. So this function should work. So the example for this function should also work. And let us find this example. Thank you so much, Mr. Das. Is send right parameter, and this will be a single parameter, right? Okay. Yes, this is a single parameter. Do I have all parameters? So actually, yes, create ID. What is your issue? Like, how is your project coming along? You've never typed before. So I'm glad that you typed since a week you followed. How's your project going? And this will be type, and I think I need to make sure that they are in order, or else I will be in a shamble. So what do we take? Param ID and param type. Param type will be correct, and param ID should also be correct. So this example should actually work, I would imagine. So let's just try it. Oh no, it will not work because we haven't updated the C side yet. So on our C side, how shall we do it now? On our C side, we shall see here. So we are called from a callback with parameter type and parameter bytes and parameter ID. Okay. So we shall, this actually will still work. Let's actually test it. I'm sure that it will work, but it's not an intended way to use it. Let's make it sure it works, and then let's change the way it works. So if it's work, then we don't need to change the firmware. We should just open this up like this, and at this point we should be able to just run our Python script. So but it's stored in a separate location. So let's cd one level up, and let's Python example x and com7. Okay, so it's almost worked, but it not actually worked. So let's see what we have on our C side. On our C side, we have nothing. So nothing worked, and everyone is happy. Nothing actually worked. So sending parameter target decline parameter write request. Okay, so there is a mismatch, it seems. And why is there a mismatch? So let's see how it works on C side and how it works on Python side. So here, do we have any errors actually? Do we have any errors in our error log? We have one. And what does this error say to us? This error says to us that I am an unknown command code. Oh, of course. I just need to change one little thing. So it will work with one little change. I'm just stupid. Okay, so let's go here. And the only change we actually need to do here is to use 22. And let's, oh my God, let's move it up. So it will be message parameter. Let's rename it. Let's actually use a rename functionality if we have it here. Rename symbol. So let's call it message write parameter to have the same style as our other messages here. We rename this, and now it should work. But it should be 22. So let's see. It works. Does it work? It says that it was sent correctly and inputted correctly. So I don't like this styling at all, but let's first see if it worked on our C side. So close errors and let's open our parameters. They are set. They are all set. So it worked. It just worked. Nice. Very nice. Let's fix this mess. How do we do this? We open the example and we go here, here, move this down, close this up, and here, instead of doing this terrible thing, we just do it like with type this, and if I want a new line, what I do is I do it like this, and I just use another print here, and I put it like that. And the value, we have a space here, so it should be all right. So let's save it and let's run it again. That is much cleaner. But also this function shall print the ID. ID is incredibly important in this example. So let's edit. Let's edit. Okay, should be very easy to do. Write request for parameter with ID, and this will be a separate print statement, and it will be f this. What? Oh, sure. It should be like this, and like that, and like this, and like that, without this ending, of course, and like this. And it also should contain this part with our ID. Param ID. Was? Param ID. No, but it should just contain param ID. Without any fancy stuff. So this will work nicely. I just forgot to add space here. This will work nicely. I also need to add a comma. This will work nicer. And let's add nothing there. So this works nicely. Okay, this looks very nice. So we sending parameter write request with or parameter ID. Too much text. Sending parameter write request for parameter ID 8 first, whatever. Type this value, device acknowledge param write request. Okay. Should I make even shorter version of the message? Sending param, actually giving that parameter is the only thing we actually send. So sending parameter, and let's just do it like this. This is much better, right? Okay, sure. Nice. So let me update my description. We re-implemented send parameter feature. Nice. And I think I will finish for the day. I need to bring my sleeping schedule lower down because I have a flight at 6 in the morning in less than a week. So we will finish for the day. Thank you everyone for watching. Thank you for being here. If you would like to see more, please follow. Tomorrow will be the last stream for me for a month, for a whole month. So it shall be fun. We will try to play music on the motors, and I hope it will be heard for people on stream. So if you want to join tomorrow, feel free to. I will be happy to have you tomorrow. And as always, thank you for watching, and I see you in the next one. Bye-bye.